start through the whole spiel.
Okay, I'm recording you.
You are recording me right now. Fantastic. Well then, let's go through and do a PM check on a Defib. Now, if you look at a Defib paperwork, essentially there's an electrical safety test and an ECG section. You would test the Defib essentially exactly like the ECG PM procedure. So I'm not going to go back through that. We have earlier videos for that. So what I'd like to do in this video is I'd like to focus on just the Defib specific tests. Now there are a couple of things that are very handy to go through, not electrical safety, but the self-test. And I really want to start here on the paddle continuity. So in order for a paddle continuity check, what I like to do, so I'm just going to turn it here to monitor on, and I'm going to press this lead select button until I get my leads to paddles. Now this is very important because what we're doing here is we're checking the continuity of the paddle. What I'm going to do is I'm going to unholster the pads. This is a good time to check the pads themselves for pits. You'll notice they slide off. These are the pediatric versions of the pads. And what I want to make sure here is I want to make sure that nothing has any types of pits on it. And this is one of the qualitative tests that we're supposed to do in ECG. Keep saying that in my Defib. So what I'm going to do here is I'm going to go ahead and I'm going to put pads together. Now you'll notice the ECG on the screen goes to a flat line. I'm going to stretch the pads and I'm going to shake them a little bit. And the reason why I'm shaking them here is I want to look for a nice even wave on this the screen. That's actually a pass. Here's what's not a pass. If it looks sudden like this, that would be an indication of a broken cable. So if you see a really sudden, stark break like that, that's actually an indication that the cabling, this pad right here, needs to be replaced. So go ahead and reconnect that portion. That is the paddle continuity check. The internal paddle energy limit, we're actually not going to check that. That is the spoon. That is the internal paddle used by surgeons when they're in surgery.
That's right. Yes,
the ones that look like spoons, yes. And normally they would cup a heart with that, and that would only be checked at 50 joules or less. And frankly, I do not have the specialized checker for that. That's a good thing to check for the people that are supporting surgical suites. We're doing a general check, so we're going to check that as not applicable, or NA, that check. Now the next one's going to be the output energy. The output energy is sort of funny because for an error, a Defib actually has a very wide range of error. It has much more than 10%. It actually has 15% error range, or 4 joules, whichever is greater. And the reason why that's there is for people who are testing at 10 joules and less, they actually have to have a 4 joule energy range. Once you get over 20 joules, it's actually best to use the 15%. So what we're going to do is we're going to do a check that's very similar to the NIBP. And that is we're going to do a low, a mid, and a high. Actually, we're going to take it at 4 stations. I'm going to go at 50, 100, 200, and 360. And that's just a personal check, personal choice. I recommend you all would start at 50 and go up to 360. Now, keeping with safety, what I'm going to do here is I'm going to make sure that from unholstering it, that I respect the pads, treat them like you would a weapon, keep it down away from people, and be very careful at this point because we are actually going to deliver several thousand volts of energy into this tester. So I'm going to push the thumb button here to charge. I've set my dial to 50 joules, and I'm going to squeeze both buttons and holster this. Looking over here on the energy measurement, I measured a 50 joule output. So that's very important. I'm going to go to 100. I'm going to show you another test. I'm going to charge this. I'm going to press just one button. The device should not discharge. I'm going to press just another button. The device should not discharge. I'm actually going to press both buttons and it should discharge. And notice the energy there was at 100 joules. Next one, I'm going to go to 200. You do not have to necessarily reholster it every time, but we'll discharge at 200.6. I'm going to go to 360, charge that. 363.7. So that gives us our output energy. And we've took a low, a couple mid, and a high energy output. Now, the next tech that I'd like to do is the max charge time and max energy. It's very important to do this test because this checks the battery's performance. On battery, so I'm going to go over here. I'm going to unplug my unit. And I am going to put the unit here on 360 joules. I want to make sure it's at its maximum energy reading. And on battery, I'm going to charge and discharge it rapidly 9 times. There's 1, 2, 3, and it's not important to measure or preserve this data, but I do know some people that will do that. They'll write down what each one of these outputs are. This is the 5th, if I'm not mistaken. 6th, 7, 8, 9, 10. Now I'm going to do the 10th charge. A nice way, by the way, to make sure that you know what the seconds are is to move to a 60 beat per minute simulation. I'm going to enter that. I'm going to exit that. I've got ECG of 60 beats per minute. So if you listen, each one of the beeps is a beat per minute. I'm going to go ahead and charge it now, and I'm going to count the number of beats, or number of, did I say 1 beat a minute before? 1 beat a second. We'll get the time right. I'm going to count the number of beats until the unit says that it's got a full charge, and it'll say it's got a full charge with that solid tone. So, ready? 1, 2, 3, 4, 4 seconds. It took 4 seconds to charge to maximum energy and gave us an output of 361.2 joules, which means the device is very accurate and very fast. It's given up to 15 seconds to charge, and the error output is given 15%. Our error was less than 1%, which is actually a very nice machine.
Is it 15% in either direction?
Yes.
Okay.
15 up or down. That sounded like a really big pop, didn't it? Yeah, make sure you're pushing solidly against all of the plates on the tester, or else you will throw an arc. And at these things are at, here it says 3,000 volts. At 3,000 volts, it makes a big pop. Okay, so what I'm going to do next is I'm going to check the synchronizer. Now the synchronizer is going to change the way that we look at our waveform here. I'm going to go ahead and push sync, and you'll notice that it'll put a little dot on the waveform. Now that dot is actually on the downslope of the pulse. We call that a QRS complex, where it goes down, up, and then down. The R is the absolute peak of an ECG waveform. So what we're going to do is we're actually going to fire the defib at 20 to 30 milliseconds after the peak of the R wave. Now this is a sweet spot, for lack of a better term. That point, that one small 10 millisecond window, will allow us to take out a spasm on the top portion of the heart without affecting the operation of the bottom portion of the heart. And that's actually a very important thing, because the heart is a cramp. It's actually 2 sets of major muscles, and the top portion alone can go into spasm without the bottom portion going into a spasm. We call that atrial fibrillation. Sync allows us to defibrillate a patient that is in atrial fibrillation without disrupting the ventricle. So let's make sure that this device fires within that sweet spot. Now I'm going to move it down to 50 joules just for safety purposes. There's no real reason to go at the max power in this one, because what I'm measuring here is more of a discharge timing. So I'm going to go ahead and I'll put this the pads on the tester. I'll charge it and I'll push both buttons. Now you're used to one, the other. Notice when I held the buttons there was a slight delay. It will not fire the defib until it measures that peak of the R wave, right where that dot is put. And in this case, the delay measured the amount of time it delayed 26 milliseconds from the peak of the R wave, and that is within our window. Our window is 20 to 30 milliseconds, so this device is actually functioning very well for us.
Okay, so it doesn't necessarily matter when you hit the discharge button. It will register you hit the button and then automatically discharge once the time has passed.
No, you have to press and hold the buttons.
Okay.
It will not discharge, if I may. It will not discharge even when you hit both buttons. Here, check this out. I was holding both buttons there, but I let go before it hit the peak of the R wave. I did it again. This time I'm going to press and hold.
Okay.
So it does not discharge until the peak of the R wave. And in this case, it was 27 milliseconds after the peak of the R wave, which there again is right in the middle of what we were looking for. So the last test, well, it's actually not the last test because I do want to do a self-test. The last thing on my sheet here is actually a energy after 61 seconds charge. Now what I'm going to do is I'm going to charge this up. The device is essentially like an energy weapon. That's how I like to tell people. A lot of people have played video games and they get the idea of charging something and holding on to a charge. Well, this charge is only good for 60 seconds. After that, the device manufacturer cannot guarantee that we're going to give the correct energy. If we cannot guarantee that we're going to give the correct energy, the best procedure is to dump the charge and then come back and recharge afterwards, right? So let's go ahead and charge.
Now, is it okay that it's still the sync button is on?
Pardon?
Is it okay the sync button is still pushed in?
Yes. I've got 10 seconds here, 9, 10. I'm actually counting the beats. And you'll notice that popping was actually the capacitor in the defib that is drying out a little. And this is just going to scream at us. Little popping there from the capacitor drying out. So this capacitor does need to be replaced at this point in time. And that's another good reason to do a check like this, is you can actually hear. That scared me. 8, 7, 6, 5, 4, 3, 2, 1, discharge. Right when I thought it would. Yeah, that popping is not good. The capacitor that's in it, we actually have one in here. May I borrow this capacitor? This is actually the size of the capacitor that defib charges. This particular one was not passing a test either, and so we ended up replacing this capacitor. And that defib has a similar capacitor, and it needs to be replaced. And we're actually going to do that next semester. I'm going to order these things so we get to have some fun. And then after we replace these, then we have to go through a full calibration on it. And boy, isn't that going to be fun too.
As long as that capacitor's not popping at me anymore, I'm okay.
Well, yeah, we're going to check that.
That is not encouraging.
We're going to check that. There is, let me see what else we've got to do that is specifically a defib only check. Looking at this, I'd say the next big thing is the self-test. After we're all done here, and I like to do this with the 60 beat per minute on there because this is going to print something for us. Charge the defib to 100. You see that it says test here. This is the self-test for the device. I'm going to go ahead and I'm going to charge, and I'm going to discharge in the wells here. I left the sync on, so I had to hold it extra long. If you look at the strip here, it's got a lot of very important things on here. We've got the date, we've got the time, we've got a 60 beat per minute because I can count the number of squares, and that one's actually perfectly timed. 5 boxes are in between each one of the peaks of the R waves, which tells us that we're at a 25 millimeter per second print. And then we've got the 60, or not 60, we got 100 joule passed at the bottom of this print. This is actually something that you would want to fill out or attach to a filled out work order and preserve. So that's it. Those are the defib specific checks that a technician would have to perform when performing a preventive maintenance check on a defibrillator.